Hi, everyone. My name is Amalia, and I will be presenting the work that we have done for the validation of the EGMS service. So I will start by explaining, first of all, what is EGMS. It is the new service of Copernicus, that it is basically a data set that it is covering all the Copernicus membrane states with ground deformation data. So basically, it's a huge data set of points that you can see how the ground is moving in all the participating members or states of Copernicus. So here, for example, I'm showing you an example of the dashboard that has been recently gone live, and it is ready for use by anyone. And I have selected randomly some points in the city of Barcelona, Sagrada Familia, just to capture your interest, that they have been building for so many years, and we see that it is moving a little bit down. So basically, everyone can enter the platform, the dashboard already, and check maybe their house, if it is moving or not. So what we have been doing, we have been participating in a project that the objective was to validate this huge data set that Copernicus has published. And the validation activity that we have been working on at SixSense had as a goal to verify the completeness of the products in terms of spatial coverage and density of measurement points. And to do that, we are using another product of Copernicus, an open product, which is the Urban Atlas classification of 2018. And if you're not aware of it, here I show an example that they take sites in Europe, and they're making a classification. They're using 27 different classes, and they are separating it, for example, continuous urban fabric. Here again, we show the example of Barcelona, that where we have green is a forest area, dark warm colors are urban fabric, and green are usually non-artificial surfaces. So what we do in this specific validation activity is to measure how many points fall in each of these classes to ensure that we get consistency with the theory, meaning that in continuous urban fabric and artificial surfaces in general, we expect to get a lot of measurement points because the technology that it is used to calculate those points, INSAR, is working better in these areas. On the other hand, we don't expect to get many points, for example, in forest areas or coastal areas or water bodies. So this has been our validation activity. In the paper that we are publishing, we are also covering a challenge that we faced during our work, which has been the overlapping bursts, because as the Sentinel-1 is scanning the Earth, we have overlapping swaths that if we measure all the points from there, we might get higher density of points in areas that they have a higher frequency of overlaps. So we are explaining a bit how this algorithm works. We have selected 12 different sites that include 8 urban sites and 4 rural sites. And those are all representing equally all the membrane sites. So the result that we get, we can draw solid conclusions about the coverage of measurement points. So here I show some preliminary results and how we are presenting them in the paper. So what we're doing is that we're calculating the measurement of points, the density of points, both for ascending and descending for each class. And here we're making a classification between artificial surfaces and non-artificial surfaces. And we see that we get a much higher density of points for the classes of artificial surfaces. We're also using other quality parameters, which are the temporal coherence and the root mean square error that can provide us even with more information about the quality of the measurement points that we have. And basically, this is all to say that we have been validating this huge data set that is available for everyone. You can actually visit it here. Currently, we're in the phase of validating all the results. In the paper, you can see some preliminary results, but soon enough, we're going to have the final reports available for everyone. And yeah, if you have any questions or if you potentially might use it in the future, you can contact me, and this is the website. Thank you very much.